This example describes Fashion Forward, a national retail chain with 240 stores, adopting an artificial intelligence-assisted scheduling partnership. The reported results include a 28% improvement in employee satisfaction with schedules and a 15% reduction in labor costs through optimized allocation. It also reports a 31% faster schedule completion time and a high adoption rate after a trial period. Operationally, the message is that combining algorithmic consistency with human review can improve both speed and quality. The system reduces manager workload while producing schedules that employees are more willing to follow. Tier 8 embeds ethics directly into scheduling. That means fairness and transparency are not afterthoughts. They are constraints and objectives that the system must respect alongside coverage and cost. Operationally, this includes fairness in distributing desirable and undesirable shifts, bias detection in assignment patterns, transparency through explanations, and continuous auditing to prevent drift. In scheduling, the ethical failure mode is often cumulative. Small unfairness repeated over weeks becomes a major workforce conflict. This tier treats fairness as a measurable, enforceable requirement, not a vague aspiration. This slide focuses on the structure of ethical constraints layered on top of operational constraints. You still must meet demand and skills, but you also enforce rules like equitable distribution of weekend assignments, equal access to overtime opportunities, and non-discriminatory patterns across protected groups. Operationally, the system must monitor fairness metrics over time, not just on one schedule. You need visibility into who gets nights, who gets weekends, who gets overtime, and whether similar employees are treated similarly. Ethical scheduling is not only about preventing legal risk, it is about protecting trust, retention, and the legitimacy of the scheduling process. This example describes Community Health Network applying value-aligned scheduling to 1,200 healthcare workers across 8 facilities. The reported outcomes include 89% employee agreement that the scheduling process is fair and transparent, and a 67% reduction in scheduling-related grievances and complaints. It also reports a 43% improvement in workforce diversity retention rates and zero discrimination lawsuits since implementation. Operationally, these results highlight that ethical constraints can improve outcomes rather than slow the system down. When fairness is built in, conflict decreases, retention improves, and the organization reduces both operational and reputational risk. These practice questions are designed as implementation drills across tiers. In Tier 1, you formulate and solve a minimum cost schedule for a restaurant scenario with multiple shifts and constraints. In Tier 2, you design a greedy priority rule and compare its cost and feasibility to the Tier 1 optimum. In Tier 3, you implement a genetic algorithm, report performance at multiple milestones, and explain why it may outperform or underperform the heuristic. In Tier 4, you design a reinforcement learning approach with a defined state, action space, reward function, and expected learning curve. In Tier 5, you describe how a digital twin integrates real-time data and what-if analyses matter. In Tier 7 and Tier 8, you design collaboration features and ethical audit processes so scheduling remains fair, transparent, and aligned with values. Labor shift scheduling is a constrained optimization problem with real operational and human impacts. Exact models give clarity and benchmarks. Heuristics provide speed. Meta-heuristics like genetic algorithms can improve quality through global search. Reinforcement learning can learn adaptive policies when the environment is dynamic. Digital twins enable continuous monitoring and re-optimization rather than static planning. The final takeaway is that a schedule is only good if it works in the real world. That means meeting coverage and skill needs, respecting labor rules, controlling cost, and maintaining fairness. The most robust approach combines formal modeling, practical algorithms, continuous data-driven adaptation, and human-centered governance. So the schedule is both executable and trusted.